Hi there, this next video is about simplifying radicals. We're focusing on numbers only and no variables. This is a very good and useful lesson for geometry and as well as algebra 2. We're going to get into variables in lessons to follow. So we have looked at seen square roots in the past when we did the quadratic formula or solved by taking the square root. And we know how to simplify into a whole number, something like the square root of 64. This is equal to 8. We could also do the square root of 36, which is 6, and the square root of 144 is 12. Now we know how to take the square root of 68 in our calculator. However, we don't want to have decimal answers anymore. This number here is not a perfect square. So we're going to show you how to simplify something so that you don't get a decimal. Now you're going to need to know how to do perfect squares up to 144 for my class. The perfect squares are numbers that are the products of two of the same number. So for example, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so on. You can see we're multiplying two of the same number together. The resulting number, 1, 4, and 9, are perfect squares. I expect you to know the list all the way up to 144, which is essentially 12 times 12. You can easily produce this list by just doing 1 squared, 2 squared, 3 squared, and so on up to 12 squared in your calculator. So let's go back to square root of 68 and let's talk about the steps that we're going to take to simplify a radical. So step number 1, you want to find the largest perfect square that divides the number. Now we're expecting you to know the numbers 1 through 144. However, those aren't the only ones that exist. There are other ones that are bigger, but you only have to have those memorized. When you do that, you're going to find that largest perfect square and write the factors. Put a square around the perfect square. It's kind of like a visual for you to use. Then you're going to write the square root of that number on the outside of the radical, and you're going to put the number left over inside the radical. And I'll show you how that works in just a moment. So sometimes the numbers are awfully large, and since we only expect you to know up to 144, you always need to make sure you're checking to see if there's no other perfect square that can come out of the radical. If there is, you must repeat steps 1 through 5. And we'll show you a couple examples of that. So let's talk about the square root of 68. When you're approaching these problems, the first thing you want to do is find the largest perfect square that's going to divide into that number. So in your calculator, you'll want to do 68 divided by 64. You'll get a decimal, so move down the line. Square 68 divided by 49. You'll get a decimal. And you're going to work your way down the perfect squares until you get one that divides into 68 evenly. The first perfect square that will divide into it is the number 4. And so what I'm going to do is put a box around the square on a fork to kind of indicate a square is like this perfect square. Now our next step is to write the square root of the number that's in the box outside of the radical. So the square root of 4 is 2. So I'm going to write that first. And the leftover number 17 is going to stay inside the radical. So the square root of 68 will simplify to 2 square root of 17. Now I want to make sure that there's no other perfect squares in 17. However, that's a prime number, so no more will divide into that. So this is all done. Let's take a look at the next one. We're going to work with the square root of 72. Ideally, we want to find the largest perfect square that divides the number. So I am going to start with the number 64 and work my way down. But let's say you know one that will divide into that. For example, I know that 9 will divide into 72 evenly. And that's a perfect square. So I'm going to break that down into 9 and 8. I'm going to put a square around the 9 because that's the perfect square. Now I'm going to take the square root of 9, and I'm going to get 3, and I'm going to put that on the outside of the radical. Now leftover number 8 is going to go inside. Now what I see here, I need now check to see if there's any other perfect squares that can come out of the radical. In actuality, in this problem, 8 can be broken up into 4 and 2. So there's another perfect square that goes in there. So what we're going to do here is I see that 4. I'm going to take the square root of 4, and I get 2. Well, that number on the outside, you're going to multiply it by 2. The leftover number is just 2. So what does that actually tell me? In the original number, square root of 72, 9 wasn't the biggest perfect square. If you work your way down the perfect square line, you'll see that 36 is actually the first one that would divide into it. This is 36 times 2. 36 is my perfect square. When I take the square root of 36, you get the answer of 6. That's the number you can write on the outside, and the 2 stays on the inside. Either way is perfectly okay. Just make sure you're always breaking it down as far as you can. Let's take a look at example 3. So we have the square root of 40. I want to find the largest perfect square that divides into that number. So thinking of the perfect squares, we've got 36, 25, 16, 9. If you were to divide all those numbers by 40, or 40 divided by all those numbers, you'll get decimals. The first one that it splits up to is 4 and 10. The perfect square is 4, so I'm going to put a box around that number. The square root of 4 is 2. That's what I'm going to write on the outside of the radical, and the 10 is going to be the leftover number. It stays inside the radical. Only perfect squares are allowed to come out. I'm double checking to make sure 10 doesn't have any perfect squares in it. It's only 2 and 5, so I know that I'm good to go. On to the next one. So in this one here, I have a number on the outside, and we kind of addressed that already in example number 1 or 2. So first I'm going to find the perfect square that goes into the number 20. The largest perfect square is 4. This is 4 times 5. 16 and 9 do not divide into the number 20. 4 is my perfect square, so I'm going to put a box around it. Now when I take the square root of 4, I get the answer of 2. Now there's already a number on the outside. So what I'm going to do with that, I'm going to multiply them. We have to keep in mind that 3 square root of 20 is 3 times the square root of 20. This is one big multiplication problem. So we're going to do 3 times that new 2, the square times the square root of 5. And now my final answer here is going to be 6 square root of 5. 5 does not have a perfect square that divides into it, so that's going to be finished. All right, on to our next one here. I have 6 times the square root of 22. We're trying to find the largest perfect square that's going to divide into that number. So starting with the next number down would be 16. 22 divided by 16 is a decimal. Moving down to the next number down would be 9. 22 divided by 9 is a decimal, followed by 4. As I can, it's still a decimal. So what's going to happen here is I can't really break this down into any of these steps. So I cannot do anything with this square root of 22. So this is considered simplified. Your answer would be 6 times the square root of 22. Why don't you go ahead and hit the pause button and give some of these a try. It's going to be worth it to do so. Go ahead and hit pause now. All right, now's the time to check and see how you did. Let your teacher know if you have any questions. As before, you're going to now move on and go take a look at the practice. Make sure you ask any questions if you have any.